Hey everyone! Welcome to TootBuy, where we turn coding mysteries into eureka moments. Today's mystery is, why does your code slow down when data grows? Spoiler, it's all about time complexity. Let's crack this case with a fun story about Mac and his missing book, and some sneaky friends. Meet Mac. His favorite book, TootBuy Code, is missing. The culprit? One of his 6 friends. Luckily, his buddy Rick knows who took it, but Rick can only point to groups, not individuals. How will Mac find the thief? Let's explore 2 detective strategies, one slow, one smart. Strategy 1, the question marathon. Mac asks every friend individually, "Do you have my book?" Each chat takes 10 minutes. Worst case, the last friend has it, 50 minutes wasted. Time complexity. Time grows linearly with the number of suspects, n equals 6. Imagine this with 100 friends. Yikes! Strategy 2, divide and conquer. Round 1. Mac splits friends into Group A3 and Group B2. Rick says, Group B has it, 10 minutes. Round 2. Mac splits Group B into B1 and B2. Rick points to B1-10 minutes. Total time, 20 minutes. This is time complexity. Time grows logarithmically. Even with 1 million friends, it'd take just approximately 20 steps. That's the power of smarter algorithms. Think of Mac's friends as data points in your code. Linear search equals checking every user in a database. It's slow for big apps. Binary search equals instantly finding a tweet in millions that is big. Oh! At TootBuy, we teach you to write code that scales. So, which strategy would you use? Let me know in the comments. If you enjoyed this detective story, smash like. Let's make YouTube's algorithm, O log n, recommend this video. Subscribe. Join TootBuy for more tech mysteries solved. Visit tootbuy.com. Get tutorials to outsmart slow code. And hey, if you see Mac's book, no spoilers. Thanks for watching. Remember, at TootBuy, we're not just teaching code. We're teaching you to think like a coding detective. See you in the next case study. Bye.